Thanks to the latest technology in paleobiorobotics, this nearly 300-million-year-old fossil is walking. This little guy is the result of years of advancements in CT scanning and is changing the way we study ancient animals. It's now evolving our perspective on how they walked and even breathed. Early tomography machines were invented to look inside your body, and with the creation of computational techniques, they have the ability to digitally reconstruct the inside of living and fossilized structures without invasive measures. But don't go running inside a paleontologist's CT machine. It's slightly different. They use micro-CT scanning, which sends higher doses of X-rays that can penetrate rock and give finer detail to specimens. This added precision helps for scanning fossils like the one used for Orobot. The original fossil for this invention is the Orobotes pabsti, first described in 2004 and thought to have roamed the Earth before the dinosaurs. This species is suspected to be the close cousin of the last common ancestor of dinosaurs, reptiles, birds, and mammals. It's also considered a stem amniote, an evolutionary link from amphibians that reproduce in water to land vertebrates who lay eggs. What makes it even more special is that it's one of the oldest known vertebrates with a fully preserved skeleton and, wait for it, footprints to match. By studying Orobotes, we'd have a greater understanding of how mammals, like us, evolved. Obviously, a fossil like this is too good to be slept on, so scientists from Switzerland and Germany teamed up to unravel the creature's locomotion. They started by analyzing X-ray videos of modern animals linked to Orobotes, like salamanders, skinks, iguanas, and caimans. Biologists observed their gait, or manner of walking, paying close attention to key biomechanics, such as how erect the animal stood on its legs, how bent its backbone was, and how its joints bent as it walked. They then created a walking computer simulation that matched perfectly with the digital footprints. This simulation identified different positions where the bones did not bump or become disjointed. And while this simulation was awesome, it couldn't exactly represent the physics of the real world. So roboticists used the digital data to create Orobot. Orobot might look vaguely familiar if you ever saw the design of Plurobot back in 2015. It was inspired by the same mechanics, but made to fit the skeletal frame of Orobotes instead. Each limb of the robot was separated into actuated joints to give it better mobility. In total, Orobot has 28 servomotors. Each one is used to move its limbs and is powered by cables linked back to a computer, which feeds Orobot its positioning reference signals, or its controls. Every leg forms a kinematic chain, which begins at the girdle and ends at the foot. But Orobot couldn't have been built without the original micro-CT scans made back in 2015. And even though not every dinosaur is becoming a robot, scans like these are revealing other unknown aspects of dinosaurs, like how some species breathed. Ankylosaurs are known for their heavily armored exteriors. Paleontologists wondered how these huge dinos stayed cool during the hot Mesozoic period. And original CT scans revealed they had long, coiled nasal passages. At first, scientists weren't sure why, but with simulations using advanced computational fluid dynamics, they simulated how the air moved within the dino's nostrils. Simulations revealed there was a significant heat exchange system within the canals. CT scans showed hot blood vessels ran along the nasal passages, losing heat to the air as it traveled through. And simultaneously, evaporation of moisture in the passages cooled down the veins, which carried blood to the brain to keep it from overheating. They basically had a built-in air conditioner. Cool. The more you know. So I hope you love CT scanning more than you ever did before, because it's practically the foundation for all this innovative research. The team from Orobot says the research in this field doesn't end here either. They hint that there's potential to build on what they have, with research considering muscles or softer tissue. You can even check out their open source data online and play and analyze on your own. So while we're not walking around with cloned dinosaurs, maybe we can walk around with robotic ones. Maybe. Orobot wasn't built in a day. The team has been working on this project for the last 8 years. I can only imagine what we'll get if we give them another decade. Don't forget to subscribe for more dino news and check out this video on how much we're still learning about Neanderthals. We'll see you next time, and thanks for watching Seeker.